Hello guys, my name is Minhajul Islam from group 324. My topic is about conformational properties of membranes. Let us consider the dynamical properties of membranes, a number of factors pointing to the high mobility of lipid bilayer. The lipids in the membrane behave like liquid crystals. It is precisely a liquid crystal that combines high orderly with fluidity and liability. This combination makes possible for membranes to perform their important functions. The liquid crystalline properties of biological membranes are determined by the fact that the lipid present in them are in a molten state at the physiological temperature. The melting temperature of a hydrocarbon is the lower, the larger is the number of double bonds of a hydrocarbon. It contains the lipid that have double bonds in their hydrocarbon chains melts at the temperature lower than the physiological temperature. The fraction of such lipids in the plasma membrane of mammals is large. The liquid properties of a membrane are proved by many factors. The mobility of the membrane structure is revealed with the aid of paramagnetic and fluorescent labels and also means by the NMR method. Figure 10.3 shows the EPR spectrum of a membrane labeled with the nitroxyl attached to the lipid tails. At a low temperature, the lipid is frozen, and at a high temperature, the spectrum is peaked since the lipid has melted. Especially throughout studies are the liquid crystalline properties of photoreceptors. Membranes contain the protein rhodopsin. There is one molecule of rhodopsin in the membrane per 60 to 90 lipid molecules, of which 80% contains an unsaturated fatty acid. The flash photometric technique has revealed that the rhodopsin molecule rotates rapidly about the axis perpendicular to the membrane plane. The time of such rotation diffusions is 20 at 20 degrees Celsius. The study of the bleaching of rhodopsin in the light by the microspectrophotometric technique has shown that the rhodopsin in the membrane undergoes translational lateral diffusion. A close value is shown by the viscosity of the cell membrane of mammals determined from translational diffusion and also by the viscosity of the membrane of mitochondria and neuroaxons. Thus, the membrane viscosity is 2 or 3 orders of magnitude higher than the viscosity of water and corresponds to the viscosity of the vegetable oil. More viscous membranes are also known to exist. There are channels in the membrane through which small ions and molecules are transported. Presumably, these channels are informed in the neighborhood of protein molecules. They are coated with the polar groups. The nature of the channels constitutes a topical problem of the physics of membrane. A number of factors indicate conformational transitions in membranes. Structural changes are detected with the aid of fluorescent and paramagnetic labels. By measuring width ranges and light scattering and by circular dichroism. In membranes, these are observed by phase transitions, the melting of the lipids. The mobility of membrane lipids and phase transitions that occur in them are determined by the conformational properties. The melting of lipids occur through the rotational isomerization in hydrocarbon chains. This is a conformational melting. The saturated hydrocarbon, that is paraffins, crystallize in the form of continuous series of Tronus rotometers. In addition to Tronus rotamers, the melting gives rise to Gaucher rotamers. Their fraction in liquid paraffinic hydrocarbon is about 10%. This is also refers to the hydrocarbon tail of the lipids. There have been worked out of the statistical mechanics of bilayer phospholipid membranes which takes account of rotamerization and interchain steric restrictions. Trouble in 1971 advances the theory of transport of molecules across the lipid membranes based on some conceptions of rotamerization of the hydrocarbon chains. The staggered rotamers are considered to be the mobile structural defects that determine the presence of free volumes in the hydrocarbon phase of a membrane. The diffusion coefficient of such kinks is estimated at 10 raised to the power minus 5 centimeters square per second. This is fast diffusion. In most cases, the response of the cell membrane to the addition of specific ligands is cooperative in character. It has been found that many drugs have an effect on the conformation of membranes and membrane lipids. James and his co-workers treated the cell membrane as an ordered cooperative system built up the interacting submolecules. They considered the triggering properties of membranes on the basis of a theory analogous to the theory of indirect cooperative on the basis of theory indirect cooperative of enzymes developed by Mond, Women and Chengs. Thank you.